whatever things we have seen, those are displayed, and what we were discussing was how to give the limits when you convert a given Cartesian double integral to polar double integral. I said that in the next lecture we will see some of the examples. Okay, so we have an integral, say for an example, double integral f of r comma theta dx dy is replaced by r dr d theta. So whenever you are going to change a given double integral in Cartesian form to polar form, this type of thing you are going to get. So you will replace x by r cos theta, y as r sin theta. So overall the integrand will reduce to the form r comma theta, and dx dy is always replaced by r dr d theta. Now what we need to see is we need to discuss the various cases in which we need to give the limits for the region R. So R is the complete circle. A complete circle x square plus y square equal to a square. Okay, so we need to evaluate this integral in each of the following regions. So the first region that I am considering is the complete circle x square plus y square equal to a square. So this complete circle is going to be there. What will be the limits? Anyone? What are going to be the limits for r? What are going to be the limits for theta? So whenever we are in a polar coordinate system, we take the step which is starting from the origin and it will be up to the curve. The value of r is going to be from
0 to a
0 to
to
a,
a
and theta is going to be from 0
to pi.
equal to 2 pi. Since it is a complete circle, this theta is going from 0 to theta equal to 2 pi. So r is the semicircle x square plus y square equal to a square, and y is greater than or equal to 0. So x square plus y square equal to a square is again a circle, but with that there is another condition, y greater than or equal to 0. So in the above quadrants, y is going to be greater than or equal to 0. So only this much part is included. So again take the step from the origin to your curve. This is my region and this area is to be covered. So small r is running from 0 to r equal to a, and theta in this case is going to be from 0
0 to pi.
0 to pi. Exactly. Third one is quite interesting, and r is the complete circle x square plus y square equal to 2x. How can we draw this circle? So we'll adjust this. Um, if I want to draw this, you can adjust this 2ax on the left hand side. So I'll do the simplification here. So x square minus 2ax plus y square. What I should do here? To make it complete square, I will add a square and subtract a square. So on the right hand side, I will have a square. So this equation is actually x minus a whole square plus y square equal to a square. So this is a circle with center a comma 0 and radius a. So a comma 0 is this point, and I'll draw the circle. Yes, who can try the limits in this case? So I'll take the strip.
Sir, R equal to 0 to 2a.
No. Look, I'll tell you the idea, as this is the first example where we have encountered something which is not obvious. Uh, I'll, what is the equation of the circle? X square plus y square equal to 2x. What I need is the limits for r and theta. Theta is very much clear. You can quickly tell me theta. What is theta? Theta is going from how you are going to rotate that strip, and what angle, minimum angle you will have and maximum angle you will have. That is quite obvious. Yes, yes, tell me.
Sir, minus pi by 2 to pi by 2.
Yes, exactly. So minus pi by 2, theta is running from minus pi by 2 to theta equal to pi by 2. Now the second thing is the distance from the center to the curve. So this is my region. I need to have minimum value of r and maximum value of r. Minimum I already know. Minimum is 0. What is the maximum? Maximum is up to this circle. Okay. So what is the equation of the circle? Equation of circle is x square plus y square equal to 2x. This idea will work in every case. You put x is equal to r cos theta, y is equal to r sin theta in this. What you will get, x square plus y square is equal to r square is equal to 2ar cos theta. R gets cancelled out, so r is equal to 2a cos theta. So on this edge of this circle, the value of r is 2a cos theta. And what is our strip? Strip is starting from the origin going to the circle. So the value of r is going from 0 to r is equal to 2a cos theta. You can identify that the same thing works here. What is the equation of the circle in the first one? X square plus y square equal to a square. So if you put x is r cos theta, y is r sin theta, you can see that you are getting r equal to a from this. Okay. So whenever you want to find the outer end of your strip, what you do is you directly put x is equal to r cos theta and y is equal to r sin theta. You will get the limits for r. That is the idea. Fourth one, where r is upper half. Okay, where r is the part of circle in first quadrant. Part of x square plus y square equal to 2ay in first quadrant. Yes, I want you to try this. Let's see who can do it. Okay, at least try to draw the circle.
Sir, theta.
Theta
Sir,
is
theta
from,
is 0 to pi by 2.
yes,
And r is from 0 to 2a cos theta. I mean sin theta.
r is equal to 0 to r equal to 2a.
2a sin theta. Sin
Exactly.
theta.
Yes, that's correct. So the circle that you get is of this form. A part of it in just the first octant. So this part is not there. In this case, theta is running from 0 to theta equal to pi by 2, and r is running from 0 to the circle. On the circle, the value of r that you are going to get is 2a sine theta. Exactly right. Where r is equal to a1 plus cos theta. Anyone, what is this?
Sir, that
A distance
heart
from
shape something.
x-axis. A
Miss,
distance from x-axis.
Heart shape. It was taught in the previous unit.
what is the value of, yes, heart shaped curve? Yes, it is correct. What are the limits? Theta is running from 0 to theta equal to,
Sir, pi.
if you remember the curve is like this. The complete area is included. So theta is running from how much strip will be rotated from 0 to the end point. Theta is running from 0 to theta equal to
2 pi.
2 pi. R is running from 0 to edge of this curve. What is the edge? At the edge, the value of R is a1 plus cos theta. The last one, where R is 1.
Sir, can you go to the previous slide once?
Sir, but here R is in negative direction even, no? In the fifth one.
uh, R can be in negative direction, but since I'm considering theta from 0 to 2 pi, then R can be considered only positive, not the negative one. I said that R becomes negative when you get at theta equal to pi, say if you are getting minus 1, R equal to minus 1. It means that it goes in the negative direction. Say pi by 2. Theta equal to pi by 2 पे minus 1 value, it means that at this point, minus 1, this point is going to be there. But theta equal to minus pi by 2 is also included. Na? At minus pi by 2, the value of R is going to be 1. So As I won't take theta negative here, I mean, I'm considering theta from 0 to 2 pi. So in that case, r cannot be negative. While drawing, considering r as vector is fine, but not in this example. Fine. Where r is one loop of r square equal to a square cos 2 theta. And what is this? Anyone remember the graph of this?
Sir, it's like
Sir,
on right
rose
side
curve.
circle and left side circle.
Is a rose curve.
So like a sort of like a 8, but with
Mm,
narrow.
Yes, sir. 8.
it is called Bernoulli's lemniscate that we have already seen. The curve is like this. At minus plus pi by 4 and minus pi by 4, you can see that it becomes 0. If you go beyond pi by 4, say pi by 2, you simply put pi by 2. Cos pi, that will become cos pi is minus 1. At theta equal to pi, you will get r square equal to minus of a square. The curve does not exist. Okay, so in this area, your curve does not exist between these two. This is the Bernoulli's lemniscate that we have already seen. Now, what is the value of theta? Theta goes from minus pi by 4 to plus pi by 4, as you can see it here. What about r? Anyone? You take the strip which is starting from origin and end at the curve. What values of r we are going to have? Be quick. What is the minimum value of r at least? Rohit, Raj,
Sir, I don't have an idea.
you don't have any idea.
Sir, 0 to a square.
0 to what's the
A
upper
square.
limit of r? What's the equation of the curve? Equation of the curve is r square equal to a square cos 2 theta. What is the value of r from this? A under root cos 2 theta, and does Rohit have no idea? Just now in previous example I explained how to give the limits for r. So r is equal to 0 to r equal to a under root cos of 2 theta.
I'm sorry, sir.
Okay, so these were all the cases. Now we will go for actually solving some of the examples related to the conversion. So we need to evaluate integral 0 to a, integral 0 to under root a square minus x square sine pi by a square in bracket a square minus x square minus y square. So we can see that the a circle is involved in this case as you combine the limits. In the limits, the conclusion that I draw is the first integral x is fixed, so strip is given strip parallel to y axis. Given strip parallel to y axis, x is running from 0 to x equal to a, y is running from 0 to y equal to under root a square minus x square. So this equation can be simplified and what we get is x square plus y square equal to a square. The strip is vertical and it starts from y equal to 0 and ends at the circle. I'll draw the circle here. The strip is vertical. It starts from y equal to 0 and ends at the circle. Moreover, x runs from 0 to a. So only this much part is there. So as it is a circle, I will convert the given integration to polar form. So what we do is we put x is equal to r cos theta, y is equal to r sin theta. When we put this dx dy, don't forget that this is a common mistake. Dx dy has to be replaced by r dr d theta. From the diagram, the new limits are going to be r is running from 0 to r equal to a, theta is running from 0 to theta equal to pi by 2. Don't forget that these values are to be substituted in the integrand also. So substituting, we get integration theta is running from 0 to pi by 2, r is running from 0 to a sine pi by a square in bracket a square minus x square plus y square is actually r square. Bracket complete. I'll rub this diagram. So dx dy is replaced by r dr d theta. Look, this can be written as the product of r and theta. You can see that both the limits are constant for theta as well as r. Moreover, this integrand is actually the product of the function of r and a function of theta. Okay, so I'll separate this. Theta is running from 0 to pi by 2 d theta. And in the next integral, r is running from 0 to a sine of pi by a square minus r square. Look, if you take the product of pi by a square in bracket a square minus r square, what we will have is pi by a square into minus 2r. So what I'm going to do is I'll multiply and divide by the remaining thing. So what I need here is minus 2 pi by a square into r dr. What extra things that I have got there? So I will multiply those minus a square divided by 2 pi. So if we integrate this, so sine of t dt is something that is there. So this is equal to pi by 2 in bracket minus a square divided by 2 pi. What is going to be the integration is cos of pi by a square in bracket a square minus r square. Integration of sine is equal to minus cos divided by pi by a square. Limits from 0 to a. So if you put the upper limit a square minus a square, you can see that the answer is going to be 0. When you put the lower limit 0, so what we will have is a square will get cancelled out, cos pi will become minus 1, this will become minus 1, cos pi is minus 1, minus minus gets cancelled out. So overall that we have is pi gets cancelled out, 4 e raised to 4, so that is minus a square divided by 4 into this is pi by a square, so this is a square divided by pi. Is there something wrong? Okay, so I think some calculation mistake. So the final answer is a square by 2. I can verify this later. I've done somewhere this. Fine. I'll go to the next example. Evaluate double integral over a dx dy divided by 1 plus x square plus y square whole square, where a is one loop of lemniscate x square plus y square whole square, which is equal to x square minus y square. The lemniscate is given better understood in polar form. So what I will do is I'll put x is equal to r cos theta, y is equal to r sin theta. When we put this, dx dy has to be replaced by r dr d theta. In order to understand the diagram, I will put the values of x and y in the equation of lemniscate. So on the left hand side, we will have r raised to 4 equal to r square common cos square theta minus sin square theta. So that is r square is equal to cos square theta minus sin square theta is cos 2 theta. So r is equal to under root r square is equal to cos of 2 theta. Thus, the equation that we have studied in curve tracing was r square equal to a square cos 2 theta. In this case, the value of a is 1. So we need to integrate this equation over one loop of this curve. There are two loops in lemniscate that we already know. So we can see that at theta equal to minus pi by 4 and plus pi by 4 it is 0. So from diagram, theta is running from minus pi by 4 to theta equal to plus pi by 4. What about r? I'll start the strip from the origin, take it up to the curve like this. So r is running from 0 to. On the curve, what is the value of r? This is the equation of the curve. R square is equal to cos 2 theta. So from this, the value of r is under root cos of 2 theta. We can put these values. So I is equal to minus pi by 4 to plus pi by 4. 0 to under root cos of 2 theta. R dr d theta upon 1 plus x square plus y square is actually r square whole square. We need to solve this integration. Minus pi by 4 to plus pi by 4. So 1 plus r square, if I put this as t, multiply and divide by 2. So 1 plus r square derivative is 2r dr. So 1 upon t square integration is minus 1 upon 1 plus r square, limits from 0 to under root cos of 2 theta d theta. Now the integration of this is going to be minus pi by 4 to plus pi by 4. When we put the upper limit, we'll have minus 1 upon 1 plus cos of 2 theta plus 1. 1 plus cos theta is equal to 2 cos square theta by 2. 1 upon cos square is equal to sec square theta by 2. So what we actually get after this is minus pi by 4 to plus pi by 4 minus sec square theta plus 1 d theta. This has to be 1 by 2. So the integration is minus 1 by 2 tan theta plus theta. Limits from minus pi by 4 to plus pi. I'm so sorry. I made a mistake here. So this is an even function. You can note that. This 1 minus 1 by 2 sec square theta is an even function. So I'll write this as 2 times 0 to pi by 4 minus 1 by 2 sec square theta plus 1 d theta. So the integration two times in bracket minus 1 by 2 integration of sec square theta is tan theta plus theta 0 to pi by 4. If we solve this, and you put the upper limit, tan pi by 4 is 1 plus pi by 4. So the total answer is pi by 4 minus 1 by 2. Okay, I'll go to the next example. Evaluate double integral over R.
Sir, what was the answer of the previous question?
Yes, pi by 4 minus 1 by 2, I guess.
Sir, it should be pi by 2
Sir,
minus.
it should be pi by 2 minus 1
Yes, sir.
because there is a 2 multiplied there.
Oh, I may be wrong then. Yes, into 2. Into 2 was there, है ना? So evaluate double integral over R y square dx dy where R is outside x square plus y square equal to ax and inside x square plus y square equal to 2ax. So if you simplify the two equations and try to identify, I'll write down the first x square plus y square. So minus ax plus a by 2 whole square. So if we simplify this, what we have x minus a by 2 whole square plus y square is equal to a by 2 whole square. And if you simplify this equation, that will turn out to be x minus a whole square plus y square equal to a square. So I will draw the diagram of this. The first circle is at the center is a by 2 comma 0 and the radius is a by 2, the smaller circle. Then you have another circle whose center is this a and radius is a. What they are saying is my region R is outside the first smaller circle and inside the larger circle. So this is our region. So if I want the area or as it is a circle, we'll convert it to polar form. Once we convert it to polar form, we'll need the values of R as well as the values of theta. So we'll put x is equal to R cos theta y is equal to r sine theta. Once we put this, dx dy has to be replaced by r dr d theta. So from the diagram, anyone who would like to comment upon the limits?
Sir, R is A to 2A.
No. So we will take a strip which is in the given region. So the strip will be like this. So we always draw the strip in our region. Okay. So what is the lower end of your strip and what is the upper end of your strip is something that you need to think of. So the lower end of your strip is on the smaller circle. Okay, so R will depend the value of R from the second circle that you get. I told you what is the idea to give the limits for R. You put x is equal to r cos theta and y is equal to r sin theta in the equation, and once you put the values of x and y, you get the value of r. So if you put x is equal to r cos theta and y is equal to r sin theta in the first equation, so that will be r is equal to a cos theta 2. R is equal to, in the second equation, if we put the same thing, we'll get r is equal to 2a cos theta. Moreover, for theta, we can observe that it is from minus pi by 2 to theta equal to pi by 2. So we'll put the values minus pi by 2 to plus pi by 2, a cos theta, 2a cos theta, y square is r square sin square theta, dx dy is replaced by r dr dt. So we can see that the
You
integrand
got
is
limit of theta.
who wants, yes, oh, didn't hear you.
Sir, how you got limit of theta?
Theta can be given from the diagram. So minus pi by 2 to plus pi by 2. So here you have the product of r and theta. So integrand can be separated. A cos theta to a cos theta. Oh, I'm so sorry. The limits of this are not constant actually. So those are interrelated. We cannot separate. In that case, only sine theta will come outside. Integration a cos theta, a sine theta, you'll have r cube dr bracket complete d theta. Okay, so we will solve both the integration. First of all, with respect to r, when we solve the integration, so minus pi by 2 to plus pi by 2. Sine theta, you'll have r raised to 4 upon 4. Limits from a cos theta to a cos of theta. Later d theta. So I'll drop the diagram now. Even the explanation of the circle, which we already discussed while we started the lecture. So we'll solve this integration. So that is minus pi by 2 to plus pi by 2 Sine theta 1 by 4 being constant will go outside. So we have 2 raised to 4, which is actually 16 a raised to 4 cos raised to 4 theta minus a raised to 4 cos raised to 4 theta. Please check the calculations. Now,
Outside there should be sine square theta, no?
where?
Outside the integral, sine square theta
Oh,
should be there.
that was y square, है ना? Yes. Thank you. So now, cos raised to 4 theta will come outside. You have a raised to 4, 16 a raised to 4 actually. A raised to 4, 16 minus 1, that is 15. 15 by 4, a raised to 4, integration minus pi by 2 to plus pi by 2, sine square theta, cos raised to 4 theta dt. Now you can see that this is an even function. So being an even function, I can make it 2 times. So this will be 15 by 2 a raised to 4, 0 to pi by 2 cos raised to 4 theta sine square theta d theta. Now using the reduction formula, I'll give the answer 15 by 2 a raised to 4. In bracket, consider the power of cos minus the even number, odd numbers. So this is 3 and 1. 2 minus 1, 1 upon, add them 4 plus 2, 6, 4, 2. Both are even, multiply by pi by 2. And so the final answer is 15 pi a raised to 4 divided by 64. This is the final answer. I hope that is correct. Fine. So just one example that will solve and then we'll stop. Double integral over r dx dy over the cardioid r is equal to 1 plus cos theta. So for cardioid we have already studied theta is running from 0 to 2 pi, r is running from 0 to the edge of the cardioid 1 plus cos theta. Dx dy, we know that when we convert to polar form, dx dy is replaced by r dr d theta. Now let's do the integration. Theta is running from 0 to 2 pi. Integration of r is r square by 2, 0 to 1 plus cos theta d theta. So this is 0 to 2 pi, 1 by 2 being constant. 1 plus cos theta is 2 cos square theta by 2 whole square d theta. So 2 square 4 by 2 is 2, 0 to 2 pi cos square theta by 2. That is Sorry. It would have been better if I kept it as it is. One plus cos theta square. 1 plus cos theta is 1 plus 2 cos theta plus cos square theta. So 2 times this is theta plus 2 sine theta plus integration cos square theta d theta and 2 outside. 0 to 2 pi. 0 to 2 pi. So this is 2 in bracket 2 pi, and when you put 0, both the terms are 0, plus 2 times 0 to 2 pi cos square theta. Does anyone
So
remember
I guess it is 1 by 2 and not just 2.
which one?
Sir, it is 1 by 2.
Outside the integration?
Yes.
Yeah.
That is what I was saying.
What about this integral 0 to 2 pi cos square theta? We have the properties of reduction formula there. So that is 4 times 0 to pi by 2 cos square theta d theta. So this is pi plus 8 integration of cos square theta pi by 2 to 1. 4 into 2. Right? So this is d. So this is how the polar form, Cartesian double integrals are converted to the polar form, and those are solved. That's all for the today's lecture. The link is given for the attendance. Thank you, everyone.